Sectra table is actually a really unique visualization of the human body. And we have 18,700 some photographs of this cadaver. And we sat and went through each one of those photographs and segmented out and 3D modeled each named anatomical structure. We took a cadaver that was donated to science, and we sectioned through it head to toe, cutting 1 millimeter at a time. And each time we did that, we took a picture.
Many programs utilize cadavers as part of the core of their anatomy experience. We started to investigate alternative methods for delivering the same kind of content. We found that this can be done equally as well with simulation.
Sectra visualization table includes a number of different elements that are provided to enhance or to be an adjunct to cadaver dissection.
Part of our offering is the VH dissector. So essentially what a student has with this software is the 3D model, which represents their patient, and then the cross sections, which would represent their clinical imaging. The difference is everything's labeled and identified and interactive.
One thing I've had a lot of success with is the ability to highlight structures. So as you scroll through the different slices of the human body, you can really see those structures and where they are related to other structures. That's a very hard thing to see, even when you're dissecting a human body.
As you rotate the cadaver, you get the real sense of the three-dimensional space, which is really what I'm looking for as the students interact with the machine.
We also offer the education portal, which are actual CT scans and MR scans and other DICOM image data sets of actual patients. This offers the opportunity for students to integrate what they learn in anatomy with clinical scenarios so that they're getting the same experience that they might in medical school or as a professional.
Instructors can use this tool as a method to give homework assignments that can be exported to learning platforms like Blackboard, or it can be used real-time in the laboratories.
So that's something that we have fun with in the lab, is being able to pull up a case on a pneumothorax and seeing different ways to visualize it, different ways to adjust the density, different ways to slice it, and then scroll through it.
Another application that we have found is trying to learn other skills. In this case, we're introducing ultrasound into our curriculum. One of the challenges for the students is to look at the ultrasound monitor and understand what the anatomy is. We're not used to seeing ultrasound images, and by using the 3 planes and the virtual cadaver at the same time, we've been able to utilize the table to enhance their learning.
But we have a whole array of clinical cases where you can see hundreds of actual patients and other cadavers where you can actually delve in and look at real pathologies. It's also a distinct difference that we have the ability to extend that information to the students and the faculty on laptops, desktops.
There's the laptop software where they can study at home. They have this for their entire stay during the program. They can take it out on clinical rotations to help them when they're planning their surgeries the next day. I would say that as we've introduced the table and the students have seen it as well as faculty and guests, they are amazed at the features and the lifelike nature of the simulations and the flexibility of the table and the products that we have.